Good day, grade 12s, and welcome to another lesson with regards to the topic of sequences and series. We're now tackling geometric sequences, which is new work to you guys, but it shouldn't be that difficult if I'm being honest. So, boys and girls, I say we jump right into it and get this over and done with. Okay. So, boys and girls, a geometric sequence is a sequence in which the ratio between consecutive terms is common. Now, boys and girls, a ratio, if you guys come to remember, I want you to keep this in mind, is written as 1 is to 2, right? And this 1 is to 2, boys and girls, if you remember properly, can be rewritten as 1 over 2, which is a half. Okay? Very important that we remember that. So now, boys and girls, a geometric sequence is, we find the general term of a geometric sequence using the formula T of n is equal to a r n minus 1, boys and girls, where a represents the first term in the sequence and r represents the common ratio. Now, boys and girls, if you think back to our work with arithmetic sequences, we remembered that in arithmetic sequences we had a d, and that d represented a common difference. In geometric sequences, we have a common ratio, which is, represented by the symbol r. Okay, and how do we find this common ratio, boys and girls? Well, I did tell you guys in the beginning, to a certain extent, the formula to finding a common ratio, or the common ratio in a geometric sequences, or finding in the geometric sequence, or finding r, is essentially T of n over T of n minus 1. In layman's terms, bigger term minus, not minus, man, excuse me, bigger term over the term less than bigger term. So example, T2 over T1, or T6 over T5, or T4 over T3, or T10 over T9. So it's always the bigger term over the term that's one less than it. Okay? All right. So the bigger one dominates and is always on the top. I want you guys to remember this. And n is essentially the position of the term in the sequence, as we all know. Now, boys and girls, if you do take anything from this lesson, I want you to take the fact that, or I want you to go home knowing that a geometric sequence, boys and girls, will always have a common ratio, meaning that T2 over T1 is equal to T3 over T2 and T4 over T3. These are equal. So I want to just quickly reiterate this. I want to say this. Listen, in case you don't understand this yet. When you're dealing with a question, boys and girls, and they tell you that this sequence that follows is geometric, you should always know that the second term over the first term is equal to the third term over the second term, and so forth. It is a very important fact, especially when solving questions whereby they give you variables and they'll ask you to solve for a variable in the sequence, and they already tell you that this sequence, boys and girls, is geometric. We'll get to this as we move along. Now, I can't emphasize this a lot again. I do say, it is important that you remember this fact. Okay? So, boys and girls, I want us to tackle questions. This way, you'll be able to understand what I've been saying this whole time, and you'll be able to see what I'm talking about, and in case it has not become clear as yet. So, in question 1, we see that we have the following term given to us. We have x minus 4, x plus 2, and 3x plus 1, and 3x plus 1, and so forth. And we are told, boys and girls, key giveaway, it's a geometric sequence. And the moment you're told something is a geometric sequence, you are most likely going to have to use this fact to solve for a variable or to solve for an unknown. Okay. Now let's quickly tackle question 1.1. Question 1.1 asks us, boys and girls, determine the value of x. Now, how do we determine the value of x? We use the fact that was given. Use the fact given. So these are free marks. They're just telling you guys. So in this case, bigger term over smaller term. So x plus 2 over x minus 4 is equal to 3x plus 1 over smaller term, which is x plus 2. Then you solve for x. And in this case, we'd have x plus 2, because we cross multiply, is equal to 3x plus 1 multiplied by x minus 4. And we'd have x squared plus 2x plus 2x plus 4 is equal to 3x squared minus 12x plus 1x minus 4. If we take everything to one side, we would then have 2x squared and negative 12x plus 1x is negative 11x. So negative 11x minus 4x is negative 15x. And then negative 4 minus 4 is negative 8. Now you plug this into your quadratic formula, boys and girls. And in this case, we'd have negative 15 squared minus 4ac all over 2a. Okay. And x is equal to, or x is equal to. And in this case, x is equal to 8, or x is equal to negative a half. These are your answers. And this would usually be a good 4 or 5 mark question. So you would get a mark for using the fact, a mark for getting to standard form, a mark for substitution, a mark for your final answer, 2 marks for your final answers. This would be 5 marks. Okay. Now question 1.2 asks us, determine the numerical values of the first 3 terms of the sequence. Determine the numerical values of the first 3 terms of the sequence, because they told us that this is actually, what am I saying now? Oh, yes. This is actually T4, T5, and T6. So they want us to find T1, T2, and T3. And what do we know so far? What we do know so far, boys and girls, is that x is equal to 8 or negative a half, right? So that being said, question 1.2, x is equal to 8, x is equal to negative a half, right? That being said, boys and girls, we know that, therefore, for example, let's say we're going to use our 8. You could use your 8 or your negative a half. Okay, let's go back to the sequence. Our original sequence was given to us as such. Just quickly rewriting it, boys and girls. X plus 2 and 3x plus 1. And in such a case, where we see an x, we'd substitute in an 8, an 8, an 8. Therefore, we would be left with 8 minus 4 is 4. 8 plus 2 is 10. As well as 3 times 8. 3 times 8 is 8, 16, 24. 24 plus 1, 25. Right? Perfect. Now, this is essentially T4, T5, and 6. Excuse me. T6. Yeah. Now, what are we going to do? We are going to look at what we already know. We already know that given these numbers, we can already find our R value in our T of n formula. And what is our R value? Our R value can be given to us as 10 over 4 and also 25 over 10. When we simplify this, we could easily simplify this by dividing by 2 divided by 2, so it would be 5 over 2. Yep, and this dividing by 5 dividing by 5, which should be 5 over 2. So therefore, we already know that R, we don't know our R. We already know our what? We already know our, we don't know our A, we already know our R. Our R is 5 over 2. And then in our T of n formula, we can just plug this in so far. A, R n minus 1, T of n is equal to A, what is our R? Our R is 5 over 2, n minus 1. Now, boys and girls, what have we been given in this sequence? We already know the fourth term. We already know the fifth term. We already know the sixth term, and we can use one of them to solve for A. And when we solve for A, we already know that we'd have the first term. And then from there on, we'd be able to plug everything into our formula. Let's go on. So you see here, we're going to, for example, let's just use, for the sake of time, let's use 25. So 25 is equal to A, 5 minus 2. Remember, n represents the term, and we say 25 is the sixth term. So we'd say 6 minus 1. All right. And from there on, we would then divide by, we'd say 25 is equal to A, 5 over 2 to the power of 5. We'd divide both sides by 5 over 2 to the power of 5. 5 over 2 to the power of 5. Thus, A would be equal to, 1 second. Just going to go back to my calculator. 5 divided by 2 all to the power, excuse me, boys and girls, I need a scientific calculator, yeah? Okay, so we know that 5 over 2 is 2,5, right? Yes. So we can easily say 2,5 all to the power of 5. That gives us 97. It gives us this whole ugly number. Now that number, so we'd say 25 divided by, excuse me, boys and girls, I apologize. Okay, here we go. 2.5 to the power of 5 gives us 97. It gives us 97, comma, 65625. 65625. So therefore, we'd say 25 divided by 97, comma, 65625. That would give us 0, 256. That doesn't make sense though.